After this video, you should be able to complete these 4 assignments in Khan Academy. Use a Pythagorean theorem to find right triangle side lengths. Use Pythagorean theorem to find isosceles triangle side lengths, right triangle side lengths, and use area of squares to visualize Pythagorean theorem. This is a very, very important topic for your future mathematics classes. So first of all, what is a right triangle? A right triangle is a triangle where one angle is exactly 90 degrees, and that's shown with this little square in the corner. The side that is opposite the right angle is always the longest side, and it's called the hypotenuse. It's always opposite the 90-degree angle. The other 2 sides are called legs, and we typically designate these with the letters A, B, and C. So we'll call this one A, we'll call this one B, and the hypotenuse is always designated with the letter C. If a triangle is a right triangle, it has to satisfy the following equation. This side length squared plus this side length squared has to equal the hypotenuse lengths squared. A squared plus B squared equals C squared. If those values satisfy this equation, it is a right triangle. If it doesn't satisfy that equation, it is not a right triangle. This is the Pythagorean theorem, and it also allows us to find missing side lengths. So if you're missing A or B or C, you can find one of those values if you know the other 2. There are some example problems where you're trying to find a missing side length. So if we look at this problem here, this side length is 3, this one's 4, and we're missing this. So we need to decide are we missing a leg or a hypotenuse. It is opposite the 90-degree angle, so this is the hypotenuse. I'm going to label that with C. So to find C, we know that 3 squared plus 4 squared equals C squared. Following the order of operations, we have to square these numbers first before we can add them. So this is 9 plus 16, which is 25, which is C squared. So what is C? C is the square root of 25. And we know that the square root of 25 is 5. So C is 5. Notice that 3 plus 4 does not equal 5. It's 3 squared plus 4 squared equals 5 squared. Let's take a look at the next one. Okay, we have 8, we have 30, and a missing side here. This is the hypotenuse. So I'm going to call this, you can call it A or B, I'll call it A. Okay, so we know that A squared plus 8 squared has to equal the hypotenuse squared. So we have A squared plus 64, 30 times 30 is 900. So A squared, right, we're going to subtract 64 from both sides. So A squared is 836. So I need to know the square root of 836, right? So A is equal to the square root of 836. Sometimes you can leave your answer like that. Sometimes you need to use a calculator. So I'm going to take the square root of 836. It's not half, it's the square root of 836. And I get 28.9. We'll round to the nearest tenth. All right, let's take a look at this one down here. So we have the hypotenuse, so we're missing this side. I'm going to label this one with B just to be different. So we're going to go 7 squared plus B squared is equal to 25 squared. So we have 49 plus B squared equals 625. We go ahead and subtract 49. Oops. And we end up with B squared is equal to 576. And if I take the square root of 576, I get a nice integer for this problem. I get 24. Okay, last problem. This time we're looking for the hypotenuse, so we're going to call that C. So we have 9 squared plus 10 squared is equal to C squared. 81 plus 100. 181 is equal to c squared. We take the square root of 181, and we should be good at estimating these now. It should be a little less than 14, I believe. And I get 13.5. Actually, it's right in between 169 and 196. Okay, here's the next type of problem. Looks a little complicated here, but let's see how we could use a Pythagorean theorem. Find x in the isosceles triangle. So an isosceles triangle has two sides that are equal and two angles that are equal. So notice that this angle and that angle are the same. That means that this side and this side will be the same. So I'm going to go ahead and label that with 26. And if that's the case, this has cut this triangle into two equal triangles as well. Okay, so this is a right angle. So if I know that and it cut this in half, then if this is 20, this side length is 10. So right now, I've got a side length, and a hypotenuse, because it's opposite the 90-degree angle. So I've got 10 squared plus, this is labeled x, so I'm going to use x, is equal to 26 squared, right? A squared plus b squared equals c squared. So I have 100 plus x squared is equal to 676. We subtract 100. So x squared is 576. I take the square root of 576 and I get 24. Okay, so x is 24. Another type of problem you can have, it'll ask you which side lengths form a right triangle, A, B, C. Okay, so we have three options. So the only way to test that is to see if 2 squared plus 3 squared equals 5 squared, the longest or the largest number. So is 2 squared plus 3 squared equal to 5 squared? Is 4 plus 9 equal to 25? No, this is not a right triangle. 2 plus 3 equals 5, but their squares don't equal one another. 6, 8, 10. Is 6 squared plus 8 squared equal to 10 squared? 36 plus 64, is that equal to 100? Yes. So this is a right triangle. About 7, 24, 25. I think we just did that. Let's see, 7 squared plus 24 squared, is that equal to 25 squared? Is 49 plus 576 equal to 25 squared, which is 625? Yes, it is. So this is also forms a right triangle. Okay, quick comment. There are these things called Pythagorean triples. Okay, they are sets of integers that form a right triangle. They're just good to memorize. 3, 4, 5 is a Pythagorean triple. 3 squared plus 4 squared equals 5 squared. 5 squared plus 12 squared equals 13 squared. 7 squared plus 24 squared equals 25 squared, etc. These 5 show up a lot in your mathematics textbooks, in math problems. The other thing that's nice is once you know these triples, well, because we know that similar triangles have the same shape, they just don't have the same size. If we know 3, 4, 5 is a triple, we also know that 6, 8, 10 is a triple. And let's multiply these all by 3. 9, 12, 15 is a triple. Multiply these all by 10. 30, 40, 50 is a triple, etc. Okay, let's do this one. Let's double it. 10, 24, 26. Multiply these by 2. 20, 48, 52, etc. Okay, good to know. Integers that form right triangles.